JEE as well as NEET also.
Yes.
It's a concept-oriented subject and the most basic subject in sciences. So in this, for JEE, there are about 20 chapters prescribed. Among these, 1 to 8 are dealt as physical chemistry. Next, 9 to 13 or 14, it seems, the organic chemistry, and the remaining inorganic chemistry. Right?
Yes.
Next
So
slide.
in physical chemistry, we
In
are
physical
dealing.
chemistry,
Yes.
what are the basic concepts of chemistry? The atomic structure, how the chemical bonds are made, how the molecules are structured, and what are the chemical thermodynamics, and a concept about the solutions, and a concept about equilibrium, chemical equilibrium, and a note on redox reactions and electrochemistry, and some explanation on chemical kinetics. These topics are dealt in physical chemistry. Coming to the inorganic chemistry, the classification of elements and their property repetitions, the P black elements, S black elements, D black elements, and F black elements. Then why you are missing this? You are uploading it, sir.
Yeah, now it is coming. D block, F block.
Why S is missed?
Where? Yeah, yeah, yeah.
S and P black elements.
Yeah, yeah,
Okay.
yeah.
Then D and F black elements. Okay.
Yeah, yeah.
So when the compounds are made, what are these coordination compounds? These all topics are included for JEE under inorganic chemistry part. Then coming to the organic chemistry part, purification and characterization of the organic compounds, how to purify the organic compounds and how to characterize, that means their qualitative properties about the organic compounds, and some basic principles in organic chemistry, the hydrocarbons which are used as fuels, the compounds containing halogens, the compounds containing hydrogen, the compounds containing nitrogen, etc., and so-called biomolecules, the molecules that are there in living cells. Then the principles that are related to practical chemistry when we are doing some practicals for analysis for something else. So what are the principles related to practical chemistry? These are the topics prescribed in JEE chemistry. As we know that the chemistry is the branch of science that studies the composition, structure, properties, changes of matter, and interaction of molecules between different substances. That is the chemistry. Then there are a total of 118 confirmed elements in periodic table, ranging from hydrogen to oganesson, that is element 118. So the modern chemistry has come into picture, and the father of chemistry is considered as the Antoine Lavoisier in the 18th century. He is a French chemist. Then there are, for the convenience, we can classify this all chemistry into 8 classifications based on the convenience. So organic chemistry is the study of carbon-containing compounds and their properties, reactions, and structures. Inorganic chemistry, the study of compounds which typically do not contain carbon-hydrogen bonds. Mainly the organic chemistry, carbon-hydrogen bonds are very important. So in the inorganic chemistry, other than that, we discuss the physical chemistry that deals with the physical principles underlying chemical reactions and the properties of matter. So when we are talking about the chemistry, for analysis of the chemistry, the techniques and methods for analyzing substances to determine their composition and concentrations, we study in the subtitle analytical chemistry. Then biochemistry is one where chemical reactions happening inside the living organisms, that is in cells. Then environmental chemistry, it is the study of chemical process occurring in the environment and the effects of human activities on this processes. Then industrial chemistry is the branch that applies chemical processes to manufacture the products on a large scale to meet the human needs. Just like, for example, pharmaceutical products. Then the theoretical chemistry, it uses the mathematical models and simulations to understand chemical behavior and predict chemical phenomena. How the chemical reactions are happening. If you want to model that in a mathematical form, how to do and how to understand, and based on the available information, how to simulate to understand that concepts. That is dealt in the theoretical chemistry. As we know that arrangement of these elements must be in an order so that we can classify into certain categories so as to study the properties of those materials in common. So the periodic table gives an understanding of arrangement of the elements in a systematic way to study, to understand, to apply for practical applications. Starting from hydrogen up to agonism, that is 118. So these are elements that are arranged in a systematic manner. So the vertical columns are called as groups. There are about 18 groups, and the horizontal rows 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 rows. In these 9
Table.
rows,
In this
there are
periodic
actually,
table.
you can say that periods. They are called as periods. Those periods, in fact, are
Columns.
there in inside
Columns.
the no, inside they are inside the periods only. So period wise, you can insert them into the based on 57 to 71 and 89 to 103. Last one is larynxium.
Lanthanide
So
series
these
and
get
actinide
included into
series.
the periods also.
Yes.
So it is an organized based on the atomic number, electronic configuration. Electronic configuration means arrangement of the electrons in the atom and recurring chemical properties. Repeatedly they will come. So for example, outermost electrons 1, outermost electrons 2. Otherwise you can say valence electrons. So it is a structured in rows and groups with elements in the same group having similar properties. We'll see that. We'll go in detail to study about the properties of this
So
periodic table.
here
See,
in
for
this
example,
in this periodic table there are metals, non-metals. Explain.
just a minute. Yeah, hold on. Just hold on. Class లో ఉన్నా రాలేదు మరి వచ్చేసి అతను అడగమని తిను. So, starting from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Up to this, everyone has to remember the atomic numbers, atomic masses. So, based on the valence electrons, the outermost electrons, they are classified into four blacks. If a, if the electron resides, outermost electron is in the S black, it is the S orbital, that is S black. Similarly, P orbital, P black, D black, F black. So this way, the tabular arrangement for chemical elements organized by increasing atomic number, electron configurations, and repeated chemical properties with elements in the same column group exhibiting similar behaviors. So the last column consists noble gases which has the stable electron configuration. Say for example, helium, two atoms, two electrons are there. That follows duet rule, most stable condition. Next, neon 10, 18, 36, 54, 86, 118. So these are all most stable electronic configuration. So we can say that inert gases, or we can say them noble gases.
Yes.
Next slide, please. So already we have discussed the groups are columns, periods are rows, and the blocks we have discussed. The focus on mastering each section is the group 1, alkali metals, and two alkaline earth metals plus hydrogen helium. In all these, s orbitals, s black, only outermost electrons stay in s orbitals. That is why this group 1 and 2 alkaline and alkali metals are there. Then p black, 13 to 18, including non-metals, metallites, and some metals. D black elements, they are transition elements. That is, they can change their color. Groups 3 to um, 12. Then F black elements, lanthanides and actinides. At the end, at the bottom of that, there are there. So the use
Mnemonics.
mnemonics for groups, create mnemonic devices to remember the elements in important groups. So how to remember this? That is no mnemonics.
Yes. Easy to remember
So
for short form of.
in order to remember, we can create our own shortcut
Yes.
methods.
Yes.
Linac rubs CS speed like that. So lithium, sodium, potassium, rubidium, cesium, francium. So to understand, to remember that, we have a thumb group, group 1. Similarly, group 17 halogens. Freaky clowns brought ice apples. The fluorine, chlorine, bromine, iodine, astatine. Instead of directly, we can groups also we can remember. So
Yes.
to visualize with the color coding, sometimes to distinguish the properties and all, you can use a color coded periodic table to identify different elements categories like metals, non-metals, noble gases, transition metals, etc. So color helps for visual grouping elements and enhancing the memory retention. So whenever you need to remember, that those colors will help us to remember fast. So group similar elements. The focus on elements that have similar chemical properties like noble gases, transition metals. So noble gases are colorless, inert gas. Uh, they cannot proceed for reactions under normal conditions. The transition metals known for forming colorful compounds. So to understand this, using flashcards, create flashcards with the elements, symbol, atomic number, and the key properties like group and period. This helps in regular recall and strengthens memory through active learning. Having some flashcards with you, for example, 118 elements are there. Each element you can prepare one flashcard. Take one today, afternoon one. Like that, if you repeatedly see it, you can able to understand that. So practicing with periodic table teaches. So many online quizzes are there. Can help to practice recognizing and placing elements. You can like Sudoku type of quizzes are there. So memorize the key trends, understanding the trends, that is atomic radius, ionization radius, energy, electronegativity, makes recognizing element position easier. As you move across a period or down a group, these trends are predictable. Then learn element symbols and names. Focus on memorizing the symbols for the elements first. Many element symbols derive from their Latin names, which can make remembering them easier.
Hello. 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 Yeah. What happened?
There is a phone.
Okay.
That phone will sometimes
Yeah.
disturb the network.
Yeah.
So consistent spaced repetition over time is key. Reviewing the periodic table frequently helps reinforce what you have learned. Just reviewing frequently. Next. So some questions are there. So in order to refresh back what you have learned. So for example, see what is the chemical formula of laughing gas and how is it used in the society? So laughing gas is nitrous oxide used as anesthetic in dentistry and surgery. And in order to tolerate the pain, if you are able to laugh, that pain will be less. So due to sedative and the pain relieving properties, that is N2O. So what gas are commonly used for cooking normally and what are they safe to use? Liquefied petroleum gas, mainly composed of propane and butane. These are used for cooking because it burns cleanly, producing minimal pollutants when used safely. Then what are PFAS and why are they considered harmful to the environment? Per and polyfluoroalkyl substances. These are the persistent environmental pollutants that accumulate in water, soil, and human bodies, causing potential health risks like cancer and immune dysfunctioning. So these are harmful. Then what are the toxic elements in the periodic table that pose risks to human health? Toxic elements like lead, mercury, cadmium, arsenic, sometimes chromium also. Chromium also.
Yes.
These are all harmful because they can cause neurological, kidney, and cardiovascular damage when ingested or inhaled into the body. These are the toxic chemicals. So, which elements are considered non-toxic are commonly found in everyday items? Elements like carbon, hydrogen, oxygen, nitrogen are non-toxic and form the basis of organic life and are found in water, air, and most living organisms. These are not harmful to the body. So, how do greenhouse gases contribute to climate change? Greenhouse gases like carbon dioxide, methane, water vapor, and some other one is there. I can't remember. So they trap the heat from Earth's atmosphere, leading to the global warming and climate changes. So that is greenhouse gas. What are the contaminants commonly found in drinking water and how do they affect the health? Contaminants like arsenic, lead, and nitrate. Even for uh, mercury, chromium also will come there. Drinking water can cause serious health issues, including cancer, developmental disorders, and gastrointestinal problems. Then, the carbon monoxide is considered a dangerous gas in homes and workplaces. What is the reason is it is colorless, odorless, and highly toxic as it binds to the hemoglobin more effectively than oxygen. Actually, the function of the hemoglobin is to transfer the oxygen from one place to the another place in the body. So instead of oxygen, if the carbon monoxide binds to the hemoglobin, that leads to carbon monoxide poisoning and
Usually,
potential.
vehicles like bus and car, they are releasing carbon monoxide only.
Yes, yeah, that is incomplete combustion. Normally, if sufficient air is there, automatically carbon plus oxygen gives carbon dioxide. Sufficiently air is not supplied due to lack of air supply. It will be incomplete combustion will form. That
Correct.
is carbon dioxide, and in addition to that, carbon monoxide will also be there.
Yes.
So, what are the main toxic gases released during industrial process and how are they controlled? Mainly, sulfur when we burn or for any purpose, sulfur dioxide, sulfur trioxide also, and carbon when fuel is burnt, carbon dioxide and carbon monoxide will also form, and nitrogens when air is exposed over the burning. Air consists of nitrogen and oxygen. Oxygen and nitrogen will react at high temperature as nitrogen oxides, NOx, X may be 1, 2, 3, like that. So these are released during industrial process and their emissions are controlled through scrubbers, filters and regulators. Some separation techniques are there. These are very much toxic. Next slide please. Next slide sir.
Yeah, yeah, I have changed.
How do fertilizers contribute to environmental contamination and what is their chemical impact? Mainly, fertilizers are used for the growth of the crops. So, mostly they contain nitrogen and phosphorus. Nitrogen and phosphorus, but normally the nutrients that are required for the plants is nitrogen, phosphorus, potassium, sulfur, NPKs. So they will be in the form of nitrates and phosphates. So when they are overused, they lead to water contamination and eutrophication, causing dead zones in the aquatic system. Eutrophication means if any nutritional elements present inside the water, there will be cells growth, mainly the algae. So that causes microorganisms to grow into them. That causes environmental contamination. Then how does understanding the periodic table help in predicting the element behavior? So already we have seen classification is based on certain properties, and the periodic table allows us to predict the chemical properties and reactivity of the elements based on their group and periods, trend like electron activity, ionization energy, atomic radius, etc. So when we deal with elements, the concept of mole is very important in chemical reactions. So the mole concept provides a bridge between atomic scale reactions and measurable quantities, allowing accurate calculations of reactants and products in a chemical reaction. So the reactants and products will be participating in proportion of their moles, not in proportion of their quantities. Next slide, sir.
Yeah.
So the second law of thermodynamics, it states that energy tends to disperse, making perfect energy conversion impossible, which impacts the efficiency of engines, batteries, and other systems. So energy can be converted from one form to the other form. But this thermodynamics, the second law of thermodynamics says that it is not possible to transfer the energy from lower temperature to higher temperature. If at all you want to transfer the energy from low temperature level to high temperature level, additional work can be done by external agencies. That is the principle of second law of thermodynamics. Second law of thermodynamics can be expressed in different ways. One such uh, statement is like this: it's impossible to transfer energy, thermal energy, from lower temperature to higher temperature. So, what is the role that chemical bonding plays in determining the physical properties of substances? The type of chemical bonding, whether it is ionic bonding or covalent bonding or metallic bonding, it determines a substance melting point, solubility, conductivity, hardness, and influence its applications in everyday materials. So what type of the bond is formed? So based on that, bond energy will be there. Whether it is ionic bond or covalent bond or metallic bond, based on that, you can make the applications in everyday materials. So for example, you are taking hydrocarbons. Bond energy is so high. So when hydrocarbons are burnt with oxygen, so much of energy will be liberated in the form of heat. That is what the principle we are using in vehicles. So the understanding of redox reactions is essential in environmental chemistry. So redox reactions are crucial in environmental process like water purification, erosion, and breakdown of pollutants help to solve key ecological challenges. One way it is reduction takes place, the other way it is oxidation takes place. So they are important in environmental processes. Next slide, please. So catalysts increase the reaction rates without being consumed. Catalyst is a substance that minimizes the activation energy of the reaction, allowing it to proceed faster while remaining unchanged. It doesn't take part in the reaction, just it gives a platform, a support for the reacting molecules to collide one with each other to give the product at lowest energy levels. So making them essential in industrial process. So the significance of buffer solutions in maintaining pH levels in biological systems. So buffer solutions resist changes in moderate changes in pH, ensuring the stability of biological process in the body, such as enzyme activity and cellular function. If the pH changes, the body composition will change. So in order to keep that pH at a constant, buffer solutions can be used. So natural buffers will act in the cells. If it is an outer environment, buffer solutions we can use. So, how is the concept of equilibrium applied in industrial chemical process? The concept of equilibrium is nothing but the state of chemical reaction system where it attains lowest possible energy levels. So, in order to optimize the operating conditions by keeping the pressure, temperature, and catalyst concentration, it is useful. So, why the transmitter transition elements are important catalysis and material science. Transition metals due to their variable oxidation state. One element can offer different number of oxidation conditions. For example, iron, if you take iron oxidation level +2 sometimes, +3 sometimes, like that. So states the ability to form complex compounds and plays a critical role in catalysis and development of strong, durable materials. The study of organic chemistry contribute to pharmaceuticals and healthcare. So organic chemistry is essential for designing and synthesizing drugs, understanding biochemical pathways, and developing new treatment for diseases impacting global healthcare significantly. Then, what is the Dalton atomic theory and why it is fundamental in chemistry? Dalton atomic theory proposes that atoms are indivisible and combine to form compounds, laying the foundation for modern chemistry. So, photoelectric effect. The photoelectric effect shows that light consists of particles, photons. Light particles are called as photons, which can eject electrons from a metal surface when striking it. That means electrons will be there in every element. If it is a metal, the metal's valence electrons are free to move anywhere. Once photoelectric energy is added in the form of radiation, light, so they instigate the electrons to come out. That is called as photoelectric effect. The significance of Poisson's rule in predicting bond character. Poisson's rule helps to predict whether a bond will become more ionic or covalent. The ionic bond is there, what is the ionic bond energy? The covalent bond is there, what is the covalent bond energy? So based on the size and charge of the ions involved, then the first law of thermodynamics apply energy conservation in a chemical reactions. So it states that energy cannot be created or destroyed, only transformed from one form to the other form. Then Raoult's law, it's important in understanding the behavior of the solutions. It explains how the vapor pressure of a solution changes based on the concentration of the solute, essential for understanding the colligative properties. Colligative properties are nothing but when a solute is dissolved in a solvent, it becomes a solution. The properties of that solution will be different from the properties of the solvent. So, what role do catalysts play in a chemical reactions according to the chemical kinetics? Catalysts lower the activation energy of the reaction, speeding up the process without being consumed. Then the periodic trend of electronegativity affect bond formation. Electronegativity differences between elements determine whether a bond will be ionic or covalent, affecting the properties of the compound. That means electronegativity is the amount of energy when electron is to be separated out. So that is different for different elements. So more the electronegativity, more it will be the ionic bond, like that. Less the electronegativity, that will be a covalent bond, like that. Next, please. What is the role of coordinates compound in biological systems? Coordination compounds such as hemoglobin, blood, all smears, they are crucial in biological processes like oxygen transport in blood. So, blood transport will be continuously taking place in the body as long as a living organism is there in an animal. So, that blood contains hemoglobin. In that hemoglobin, there will be iron. So, around the iron, there will be some ligands. So, the function of this hemoglobin is to transfer the oxygen from one position to the other position. Then, how do colligative properties like boiling point elevation determine the molecular masses? So colligative properties depend on the number of particles in the solution, and measuring changes like boiling point elevation helps to calculate molecular masses. The more the vapor pressure, the less will be vapor pressure, like that. So why is the Nernst equation crucial in electrochemistry? The Nernst equation relates cell potential to ion concentration, helping to calculate the voltage of the electrochemical cells in various conditions. There is an equation found by Nernst. Matter and its nature, matter is anything that occupies space and has mass, existing in three states: solid, liquid, and gas. The atomic theory says that all matter is made up of indivisible atoms which combine to form molecules and compounds. The mole concept is the mass of an atom or molecule equal to its molecular weight. That is, one mole consists of Avogadro number of molecules or atoms. Next,
One Avogadro number is
Avogadro number is 6.023 10 power 23
particles.
entities. Those entities either may be electrons or protons or neutrons or atoms or molecules. It's a number, that's all. So, law of chemical combination. The law of chemical combination includes the laws of conservation of mass, law of definite proportions, and multiple proportions governing how substances combine to form compounds. That means law of conservation of mass, what it says, mass cannot be created or destroyed. And law of definite proportions means one A plus B gives some product R, there will be a definite proportion. And suppose, for example, multiple proportions, carbon plus oxygen gives carbon dioxide, carbon plus half oxygen will give you carbon monoxide, that is multiple proportions. So, how the substances combine to form the compounds? That is, these are all laws of chemical combination. Heisenberg uncertainty principle. If you go to um, electrons, the Heisenberg uncertainty principle state that it is impossible to simultaneously know both the exact position and the momentum of an electron. An electron will be revolving around the nucleus at a particular time. What is the position we can say, or what is the momentum of
ఏం సార్ ఎనీ కాల్ వచ్చిందా?
అది కాల్ వస్తే డిస్టర్బ్ అయిపోతుంది. కాల్స్ లేకుండా చేస్తుంది.
ఓకే, నెక్స్ట్.
So, law of chemical combination is done. Heisenberg uncertainty principle is there. The significance of molecular orbital. So, when you take an atom, the electron path is called as orbital. That is an atomic orbital. If two or more atoms are forming one molecule, the resultant orbital will be different. It will not be the same. It's called as hybrid orbitals. So it explains how atomic orbitals combine to form molecular orbitals, which describe the bonding, anti-bonding interactions, the overall electronic structure of molecules. Next. Next step is. So the second law of thermodynamics applies in terms of the chemical reactions. This is another statement of second law of thermodynamics. So it states that the entropy, the extent of disorderness of an isolated system always increases in a spontaneous process, governing the direction of the chemical reaction. So spontaneous process means without any stimulation. So if the heat of reaction is negative, then it's a spontaneous process. If the heat of reaction is negative, positive, that means we need to add some energy. It's not non-spontaneous reaction. So Raoult's law already have discussed it. And
Raoult's law
the Lee
states that
Shackler
the
principle.
vapor pressure of a solvent in a solution decreases in proportion to the mole fraction of solute particles added to it. Okay, next.
Then the Lee Chatelier principle. It is Lee Chatelier. Some people call it as Lee Chatelier principle. So for a chemical equilibrium, When a system at equilibrium, it is if you disturb it by changing the external parameters like temperature, pressure, or concentration, it will shift in the direction that minimizes the disturbance to restore the equilibrium. Already system is in equilibrium. If you disturb with the temperature, pressure, or any other concentration, again it will shift to some other direction.
Okay.
It's called as
Lee Chatelier's principle. Lee
Leach-Chatelier
Chatelier's.
principle. So towards which direction it goes and all, that will be described by the Leach-Chatelier principle. So the next equation used for the electrochemistry relates the cell potential of electrochemical cell to the concentration of reacting ions, allowing for calculation of cell voltage under non-standard conditions. So, what is the half-life in the chemical reactions? The half-life of a reaction is the time required for half of the reactants to be converted into product. It is crucial for understanding reaction rates and mechanisms. So, what is the lanthanide contraction and why it is important? Lanthanide contraction refers to the gradual decrease in the atomic and ionic radii of lanthanides, affecting the properties of subsequent elements in periodic table. Lanthanides from 57 to 71, something like. So, they okay. Then a principle behind Cannizzaro reaction. In most of the reactions represented by names of their scientists in organic chemistry, this is one type of chemical reaction where it involves the
Ah,
base disappropriation of aldehydes lacking alpha hydrogen atoms, producing an alcohol and a carboxylate salt. This is called as
Cannizzaro reaction.
Cannizzaro reaction. So the significance of Heisenberg uncertainty principle.
Now, where
What
we
is
can use this Cannizzaro reaction in real time?
real time only? These are all science is a real fact.
Yeah,
There
that's
is
what I
nothing
am
hypothetical.
asking. Cannizzaro reaction, can you give real time example we can see in our day to day life where it is? Aldehydes,
Uh,
aldehydes lacking
aldehyde
alpha
lacking
hydrogen atoms, producing
aldehyde
an
means
alcohol and
CHO
a
group.
carboxyl. Okay, I understood. No problem. Carry on. Next.
Alpha hydrogen that means first carbon.
Yes,
There will be
yes,
a chain of carbons. First carbon is alpha
yes.
hydrogen atoms,
Yeah,
producing an alcohol and carboxylic acid.
yeah. That produces alcohol actually.
Aldehyde groups convert into that form.
Yes, yes, yes. I understand.
Can generate reaction.
Yeah.
Now this Heisenberg uncertainty principle states it's that impossible to precisely measure both the position and momentum of
At,
electrons simultaneously,
at a time.
meaning
At
the
a time.
more
It is not
accurately one
possible.
is
Yeah.
not less accurately other than other can be determined. So how does the valence cell electron pair repulsion theory helps in predicting molecular shapes? Because of valence cell means outermost cell where the valence electrons are there. So this theory predicts that the shape of molecules by assuming that electron pairs around a central atom will arrange themselves to minimize repulsions. So electron, there are it's a pair. So they are like entities, like charges. Like charge will always repel.
Yes.
So to minimize that repulsion, resulting in the specific molecular geometries like linear, trigonal,
Yes.
planar, different shapes. Why it happens is because of the pair repulsions. So
Yes.
there are some basic concepts in the form of questionnaire in unit wise. You see, for example, you see what is the nature of the matter. Matter is nothing but something that has mass and existing in solid or liquid.
Yeah, this is according
Yeah.
to JEE main syllabus. There are 20 units. According to that one,
Yes,
we are
yes.
discussing. Yeah.
Yes, yes. So just recapitulate the questionnaire, just like for to discuss that questions as per the syllabus. Dalton atomic theory that says all the matter is made up of individual atoms that combine to form the products. Then the laws of combination, including law of definite proportions, law of conservation of mass, and how these elements combine to form the compounds. The mole concept, as we know that if you take a mole of any substance, there will be 6.023 into 10 power 23 particles in number. For example, if you take carbon, its molecular weight is atomic weight is 12. Therefore, 12 grams is one mole. That mole. that 12 grams of carbon will have this many number of particles, that is n number of particles. And stoichiometry represents the proportion of reactants and products in a chemical reaction. Then atomic structure. What is photoelectric effect? It is the emission of electrons from a metal surface when light is striking on this. What is Bohr models of hydrogen atom? It explains that electrons orbit the nucleus in quantized energy levels, emitting or absorbing heat. Suppose electron is revolving around the nucleus. If it has to go to a higher level, it has to absorb the energy. If it by losing some energy, it comes to lower level, like that. So de Broglie's relationship says that matter has both wave-like and particle-like properties described by the wavelength h by mv. H is the Planck's constant, mv is the momentum. So Heisenberg uncertainty principle. It's impossible to simultaneously know the both exact positions and momentum of an electron. See, what is Aufbau principle in electronic configuration? Aufbau principle states that electrons fill the lowest available energy of orbitals first before filling the higher ones. So when another electron is coming to join the atom, it accommodates the lower level energy level. So
Yes.
then coming to the chemical bonding and molecular structure, ionic bond is nothing but the
Unit 3 in physical chemistry, we are discussing about chemical bonding.
yes. So third chapter, chemical bonding and molecular structure in physical chemistry. This occurs, ionic bond occurs when electrons are transferred between atoms, creating oppositely charged ions that attract each other. So the covalent bonding involves the sharing of electrons between atoms. There is another one, coordinate covalent bond.
Yes.
So in that, one atom will share two electrons and both together will share. That is coordinate covalent bonding. That we will see later.
Yes.
Then valence shell electron pair repulsion makes the structure of the molecules.
Yeah. Shape.
That predicts the shape and structure both you can say
Even
synonymous.
architecture. Yeah.
Then the concept of hybridization. Hybridization is the mixing of atomic orbitals to form new orbitals that explain the molecular shapes and bonding.
Yes.
Hydrogen bonding is a strong intermolecular force where hydrogen is attracted to a highly electronegative atoms like oxygen or nitrogen or even for this halogens that also can act.
Yes.
Then
Halogens also comes under.
yes, there are halogens are electronegative elements.
Yeah, that I know. Okay. In the hydrogen bonding,
That
we can consider.
electronegative is like saying, not saying the entire then chemical thermodynamics.
Yes.
Thermodynamics deals with the energy levels of the materials. The first law of thermodynamics states that energy cannot be created at a state and only transferred from
That is
one
called
form to another.
law of conservation. Na? Energy cannot be
Law of
created
conservation
at.
of energy. That is
Yeah.
the principle of first law of thermodynamics is based on the law of conservation of energy
Okay,
only.
okay, okay. I understood. Yeah.
The thermodynamics says that the conversion between the heat and work.
Yes, yes. That is true.
So entropy, it's a measure of disorderedness or randomness in a system, increasing
Spa.
in spontaneous process. Disorderedness,
Yes.
randomness. So Gibbs free energy determines the spontaneity of a process, where a negative delta G indicates a spontaneous process. Then Hess law, this is one important. Hess law states that total enthalpy change of a reaction is same regardless of enthalpy. For example, there is one reaction, immediately that reaction spontaneously will not happen. One reaction happens first, the another reaction consequently will happen second. As a result, some products, for example, A plus B giving some product R, that is a reaction. Initially, this process will not take place in single reaction step. A plus B gives some AB, then AB upon degradation of another reaction, it will form C. There are two paths. So Tesla says that the enthalpy change of a reaction the sum of the individual reactions. That so the second law of thermodynamics states the entropy of an isolated system always increasing in a spontaneous process. So some repeated questions are there. Coming to the solutions, molality is the concentration, number of moles dissolved in 1 kilogram of the solvent. The correlative properties are depend on the number of solute particles in the otherwise in the concentration in a solution affecting the boiling point elevation, freezing point depression, and osmotic pressure. Osmotic pressure is nothing but the pressure that is accepted by pure component. Then, what is Raoult's law? That we know the vapor pressure of a solvent in a solution decreases as the mole fraction of the solute increases. Vapor pressure of a solvent when a solution decreases as the mole fraction of the increases. Right. Then what is the Van 't Hoff factor? Van 't Hoff factor accounts for the effect of solution ionization in colligative properties. So deep going in these questions are all peripheral to the syllabus. If you go
Yes.
in detail, some of the example questions we are discussing here.
Yes.
So then chemical equilibrium. Already you have seen that dynamic equilibrium. Dynamic equilibrium is a continuous instantaneous process. The rate of forward reaction and rate of backward reaction or reverse reaction are equal with no net change in the reactant or product concentrations. Then when the reaction chemical equilibrium attains, Le principle states that a system at equilibrium will shift to counteract a disturbance in a concentration, pressure or temperature. If any parameters of this will change, it will try to reach the new equilibrium condition. Then common ion effect is one. When one common ion is added to the solution, the solubility of the compound when solution already contains one of its ions, that there will be a change. So buffer solution is yes, solution which resists changes in pH for small amounts of acid or bases are added, keeping the stable pH. Next slide, please. Redox reactions and electrochemistry. What is oxidation? Oxidation is loss of electrons during a chemical reaction. In other words, addition of oxygen also. What is reduction? Reduction is the gain of electrons during a chemical. This is the modern concept of oxidation and reaction. Earlier, in olden days, addition of oxygen was considered to be the oxidation, and deletion of the oxygen is called as considered to be reduction. So an electrochemical cell, what is that? Electrochemical cell converts the chemical energy into electrical energy through redox reactions. One way the electron will be removed, the other way the electron will be gained. When the electrons are passing, it is nothing but the electrical energy. That is what it is happening in electrochemical cell. Then Polar's law, it states that the limiting molar conductivity of an electrolyte is sum of the individual contributions of its ions. Electrolyte is nothing but a solution where
Yes.
in which two electrodes are kept.
Yes.
So the contribution of small ions will affect on that.
Yes.
The sum of the individual contributions of that. So unit 8, that is chemical kinetics, that is the variation of com- compositions of composition with respect to time. What is the rate of reaction of a reaction? That is, the rate of chemical reaction is the change in concentration of the reactant or product or unit time. Then Arrhenius equation describes how reaction rates increase with temperature relating to a rate constant to activation energy and temperature. K is equal to K0 e power minus E by RT. That is one Arrhenius equation. So where E is the activation energy and T is the absolute temperature. So activation energy is the minimum energy required for the reactants to undergo a chemical reaction to proceed to further produce products. Next.
Inorganic
So
chemistry.
up to
So far we
8
have
chapters we have.
discussed about physical chemistry. Now we are moving to inorganic chemistry.
So when in inorganic chemistry, first immediately we'll come to the topic of elements and their arrangements and
Yes.
the property periodicities. So modern periodic law, it states that the properties of elements are periodic functions of their atomic numbers. This definition is old. New definition is that the modern periodic states that the properties of elements are periodic functions of their atomic configurations instead. When the electronic configuration changes, the properties will be repeated. So
Yes.
modern definition, we check it, more periodic functions are there,
Yes, sir.
electronic configurations.
Okay, no problem.
Okay.
I'll check it.
Then ionization enthalpy is the energy required to remove an electron from an atom in its gaseous state. Suppose an atom is there, if you want to remove that one electron, that is called as the ionization enthalpy. Then P black elements. What are general trends in P black elements? P black elements show the trends in electronegativity, ionization energy, and reactivity across periods and groups. So along the period, how they change, along the group, how they change, like that. Next slide, please. D and F black elements. These are also called as transition elements. So they are characterized by variable oxidation states. They are colored compounds and they act as catalysts because of their crystalline structures. Then the coordination compound, unit 12. So a coordination compound consists of a central metal atom or ion bonded to surrounding ligands, forming the complex ions. That is dealt in the coordinate compounds. Then coming to organic chemistry part, purification and characterization of organic compounds. So how to purify? There are so many techniques. Among them, there are so many techniques. They are all, each technique has its own principle. Based on a certain principle, this separation can be done. For example, the chromatography. Chromatography is a separation technique that separates compound based on their movement through a stationary phase. It is called as a selective adsorption. A, a stationary phase is there and moving phase is there. While passing them, say for example, people are going, a train is coming. Train what? There are so many people. So one person will get down at one place, other person will get down at another place. Their respective place they will get down. Like that, at their respective sites they will be adjourned, separated. So there are some principles. What is the inductive effect? So the inductive effect is the shifting of electron density along a chain of atoms in response to an electronegative atom or group. Already there is an element, there is a compound. In that, electrons are arranged in such a way that according to their
చెప్పు రవి, నేను
bond.
ట్రైనింగ్లో ఉన్నాను రవి, ఏం
So
అర్జెంటా?
the density, electron density means if any other electronegative is there, element is there, that means
నేను
they can
చేస్తాను.
attract or give electrons. The density will be affected. So electronegative atom or group, electron density will change. That is called as inductive effect. Because of an electronegative atom, electron density will change from one location to the other location when they are exposed to the electronegative atoms or groups. Then what is resonance in organic chemistry? Resonance is the movement, dynamic movement. Resonance involves the delocalization of electrons across the multiple atoms, stabilizing the molecule. That what you call electrons will not be at the same location, so they will be vibrating around a certain distance. That is called as resonance. So in order to keep that molecule stable, there will be a resonance of the electrons. Next slide, please. So, in the 15th chapter, hydrocarbons, we are saying that carbon, hydrogen, these are only the atoms present in hydrocarbons. They are used as fuels. The geometrical isomers are there. Geometrical isomers occurs when alkenes have different spatial arrangements of groups around a double bond like cis and trans forms. So arrangement of that, because of the arrangement of these groups, there will be geometrical isomerisms. Then organic compounds containing halogens. So, for example, DDT is a toxic wildlife, wild it's an insecticide. Dichloro, diethyl, something, it's a tetraethane, tetrachloric acid, something like. So, it's a toxic insecticide. And freon, chlorofluorocarbon,
Yes.
to contribute to the ozone layer depletion.
Yes.
So, then next, organic compounds mixing with oxygen, most of them are carbohydrates, which are the energy sources for the food. So in these reactions, Riemann reaction, it forms phenolic aldehydes by reacting phenols with chloroform in presence of base. That is Riemann-Tiemann equation. That mechanism is explained by Riemann and Tiemann. Then organic compounds containing nitrogen, they are called as azonium salts. Diazonium, for example, diazonium salts are organic compounds used in the synthesis of dyes colors involving nitrogen cations bound to an aryl or alkyl group. Aryl group means spherical group, alkyl group
Now,
means open.
Disonium salts. Can you give a real time example?
For example, amine, what you call C6H5NH2. This is called as toluene. Benzene is there, C6H6. For that,
Okay.
if some NH2 group is added, it becomes toluene.
Okay. Okay. Disonium
Like that,
salts. Yeah.
diazonium salts.
Okay.
They are used in dyes.
Okay.
Then coming to the biomolecules, mostly the carbohydrates are organic molecule composed of carbon, hydrogen, and oxygen, serving as energy sources and structural components. Like other biomolecules are also there, like lipids, DNA, RNA, carboxylic acid, like this. And for practical chemistry, based on certain principles, we need to do the practicals. Some reagents are used, for example, Morse salt. Morse salt is a double salt of ferrous sulfate and ammonium sulfate used in redox reactions, titrations. And the principle behind enthalpy of neutralization is that enthalpy of neutralization is the heat change that occurs when an acid and base react to form the water, typically releasing some energy, which is mostly an exothermic reaction.
Wait,
That
wait,
is,
1 second.
yeah.
Wait, 1 minute.
These are some of the example questions that we come across in our syllabus. Getting back to the concepts again,
1 second.
this way. Yes, can I start?
Sir, chapati.
So this is again recapitulation of all the topics we have
Yes,
discussed
yes,
so
yes. No
far.
problem. Please repeat.
A matter is anything that occupies some space and has some mass,
Yes.
existing in three forms, like solid, liquids, or gases.
Yes.
That is about the matter and its nature. So the atomic theory proposed by the Dalton states that atoms are indivisible particles that form the basis of all matter, combining to form molecules and compounds. One atom may form uh, two or more atoms may form molecules, and that molecules and in turn will form compounds. So there are various laws of chemical combination. And these laws govern the ways elements to combine to form compounds, including the law of conservation of mass, law of definite proportions, etc., and atomic and molecular masses. The atomic mass is the weighted average of mass of an atom, and molecular mass is the sum of atomic masses in a molecule. Then mole concept and molar mass. A mole is a quantity of substance containing as many entities as shown as atoms in carbon 12 grams. Our molar mass is the mass of one mole of a substance. This concept is very important. A mole is nothing but mass of that molecule equal to its molar mass.
Okay.
That's all. In every mole of atom or molecule, n number of molecules, entities will be there, either it is molecule or an atom,
Why
right?
why it has given here 12 grams of carbon? Okay, okay.
That's why that's what. If you take 12 grams of carbon, its atomic weight is 12 grams.
Yes, yes, understood, understood. And
If, for example, sodium hydroxide is there, it's a molecule. So we call
NaOH.
it as molecular weight. Molecular weight is 40.
One second,
So
one
40
second, one
grams of.
second, sir, 1 second. Okay, sir. I got call from Liberia for a
Okay.
police clearance certificate. Muhammad Kai, Masa Kai. His name is
Uh,
a police from Liberia. He called me, but I
okay.
don't know. Okay, continue.
Post one message stating that I'm so and so stating staying here like that.
No, no, no. See, just see your WhatsApp message. I have sent already for police clearance certificate. Just now he called and he's not taking my call. It's okay, no problem. Morning I have done all these things with all fingerprints they have taken,
Uh,
and I have sent. Now I am expecting PCC certificate from Liberia, of Government of Republic of Liberia, but I don't
they are
know.
corrupted, na? They may expect something else, na?
Yes, I have given 150 US dollars. What else? Already
You
I
paid,
have
ah?
given. Yes.
They will give. They will send no problem. They will clear.
Yeah.
Okay.
Yeah. Please continue.
So mole is
Yeah.
equal to its molecular weight.
Yes, yes.
For example, sodium hydroxide, its molecular weight is 40. 40
Yes.
grams of sodium hydroxide will have one mole. That mole is nothing but
Yeah, you got call?
again some call
Okay.
scam beware.
Okay, okay. Next.
Right. Next slide.
Yeah.
It seems that you are learning, in fact.
Yeah, I'm learning.
So composition means the proportion of components that are present in a mixture. If it
Yes.
is based on the per 100, that is percentage composition. So the mass percentage of each element in a compound is called as percentage composition. So for example, there are three components A, B, C. If you want percentage composition of A, that is mass of A divided by mass of A plus mass of B, mass of C multiplied by 100 will give you mass percentage of component A. Similarly, component B, mass B divided by total mass multiplied by 100, like that. So molecular formula is general formula that we normally represent, and The empirical formula is the simplest whole number ratio of atoms in a compound. That is, the molecular formula shows the total actual numbers and, and the proportion of those molecules in a systematic way. That is empirical formula. So molecular formula is equal to some number into the empirical formula. The chemical equations A plus B giving some product R, that is a chemical equation. How many number of moles of A, how many number of moles of B, and how many moles of C are participating in the reaction, that shows that stoichiometry of that reaction. The electromagnetic radiation is nothing but one radiation is it's a form of energy like light that travel at the speed of light and exhibit wave and natural dual properties. Photoelectric effect, the emission of electrons from a metal when exposed to light. It illustrates the particle nature of the light.
Yes.
Based on the Bohr atomic model. So the Bohr atomic model is applicable for one electron atoms only. So it's a model where electron revolves in a fixed orbits with energy levels quantized. And we know that the dual nature of the matter, it exhibits both wave-like and particle-like behavior, as explained in the de Broglie's hypothesis.
Example, any example?
What is the
Yeah.
dual nature?
Both forms like wave nature and particle nature
It
behavior.
will be in a wave nature. And if when particles
No,
are moving in a
example I am asking. Example, which
say for example, listen, light is there.
yes, light
Normally the
having wave
particles will
like
go.
yeah,
Listen,
wave.
listen.
Uh,
The particle will go in a straight way.
yes,
That is the particle nature.
yes,
Wave
correct.
is wave is in up and down movement,
Sinusoidal wave,
vibrational movement.
yeah, sinusoidal wave and
So
yeah, flow of
that
electrons.
light is behaving like a dual in nature.
Yes, correct,
So
correct.
it's behaving like a wave and it's also behaving like a
Yeah, that you
particle.
have to give the example. Light is a best example for dual nature of matter. Yeah,
When a particle is moving towards one direction,
yeah,
it doesn't go in a small path. It will move around a certain wave movement, up and
yes,
down. Not exact path, it will not uh, move around a net axis or that axis in the above and down it will go. That is wave nature.
yes, yes,
And Heisenberg proposes that it's impossible to find the exact position and momentum of an electron simultaneously. Then
yes,
quantum mechanical model of an atom that describes electrons as a wave function in orbitals with the specific quantum numbers defining their energy and shape. Then Auger principle and Pauli's exclusion principle and Hund's rule. These rules guide the arrangement of electrons in the orbitals, emphasize the energy levels, exclusion, and maximum multiplicity. Auger principle, that means the filling of the electrons starts from lowest energy levels. And Pauli's exclusion principle says that in one orbital, it is possible to accommodate only two electrons. One will be in uh, clockwise direction, the other will be in anti-clockwise direction. And Bund's rule says that while electrons are passing uh, added to an atom, first they fill the outermost orbitals. Single atoms, electrons will be filled, and after that orbital is filled up, and then the pairing will start. Electron pairs will form only when the orbitals are half filled. In one orbital, one electron. Another orbital, one another electron. Like
yes,
that, outermost orbitals, if you take, once they are filled in single
yes,
electrons, then they start pairing. That is
yes,
full scale. Ionic bonding is nothing but the electrostatic bond between positive and negative charged particles. Covalent bonding is sharing of electrons between atoms to achieve stable configuration. Coordinate covalent bonding is there, that also is nothing but the pair of electrons will be shared by one atom and these will be shared by other atoms also. As a result, they make a form bond that is called as covalent bond. Enthalpy, energy released when the gaseous ions form a solid ionic lattice. Ionic lattice is nothing but a different arrangement of the molecules or atoms. So then valence shell electron pair repulsion. Outermost electron shell, electrons are there, electron pairs are there. They used to repel one with each other because they are in same charge. So it predicts the shapes of molecules based on repulsion between electron pairs and the valency shell. Valency bond theory and hybridization. Covalent bonds formed by overlapping atomic orbitals and hybridization takes place, mixing sp and d orbitals.
Orbitals.
As
Yes.
result of that, hybridized molecules will be formed.
Yes.
Then molecular orbital theory. It describes the bonding in molecules through molecular orbitals formed by the combination of atomic orbitals. There is one atom, it will have its own orbitals. Similarly, like or unlike atoms are there, those atoms, when they form a molecule, that they form a different resultant orbital. So that is explained in the molecular orbital theory. Metallic bond is a bond formed by the delocalized sharing of electrons in a metal lattice. Thermodynamics, the study of energy changes, especially heat and work, and internal energy in the systems. The first law of thermodynamics deals with energy conservation. Energy cannot be created or destroyed. It may be transferred from uh, one form to the other. Second law, thermodynamics states the entropy of an isolated system is always increases in a spontaneous process.
Yes.
Then Gibbs free energy, it is the energy associated with the chemical reaction that can be used to do work where negative values indicate spontaneous reactions. If the heat of reaction is negative, the reaction happens spontaneously. If the heat of reaction is positive, that means we need to add some energy, it's not spontaneous. Unless you add energy, the reaction will not take place. Raoult's law states that the vapor pressure of an ideal solution depends on the vapor pressure of each component and its mole fraction in the liquid. And colligative properties are the properties that are exhibited by a solution when a solid is dissolved in that. These are the boiling point elevation and freezing point depression, etc. And when reaction reaches an equilibrium condition, it will be an instantaneous process where the rate of forward reaction will be equal to the rate of backward reaction, and it always continuously happens. Therefore, it is called as dynamic state. Since the concentrations of all the reactants and products are remain constant, we can say it is a steady state dynamic equilibrium condition. When an equilibrium is existing in a chemical reaction system, if you disturb it by changing any one of the parameters like temperature, pressure, or concentration, accordingly, the new equilibrium condition will reach. That depends on the principle of the Le Chatelier.
Yes. Redox reaction.
Reactions involving transfer of electrons where one species is oxidated and another is reduced. Oxidation is nothing but removal of electron. Reduction is nothing but addition of electron. So these two
Yes.
reactions will happen. This happen. Reactions are important in electrochemical reactions where chemical energy is converted as electrical energy by keeping an electrolyte and arranging two electrodes inside that solution. So those are called as electrochemical cells. These are the devices that convert chemical energy into electrical energy with a galvanic cell generating spontaneous electricity production. So that is governed by the Nernst equation where the cell potential is related with the concentration, temperature, and pressure in the electrochemical cell. The rate of reaction is nothing but the change in concentration of the reactants or products in unit time, and these are affected by factors such as temperature and concentration. So the relation between the rate constant and temperature and activation energy is defined by Arrhenius.
The
K is
rate
equal
of
to K naught
constant. Yeah.
is a reaction rate constant.
Yeah.
K is equal to K naught e power minus E by RT, where E is the activation energy, T is the absolute temperature.
Yes.
Then the The trends in element properties such as atomic radius, ionization energy, electronegativity, and all other properties will change according to the periodic position of the elements. D and F black elements, these are called as metals known for variable oxidation states. Therefore, they can be used as the catalytic catalysts and for the formation of colored compounds for practical purposes. Then coordination compounds, these compounds where central metal ions are bound to surrounding ligands with important applications in biological systems and industries. Then to purify the organic compounds like distillation, chromatography, filtration, drying, crystallization, these are all the separation techniques to use and identify the organic compounds. Then isomerization is a phenomenon where compounds have the same molecular formula but differ in their structures, leading to different properties. Next slide, please.
Yeah. Hydrocarbons.
So hydrocarbons are the organic compounds consisting hydrogen and carbon. There
Include
are
alkanes.
saturated hydrocarbons called alkanes, unsaturated hydrocarbons called alkenes and alkynes. So saturated carbons are uh, in carbon there will be a single bond between hydrogen and carbon. In alkanes there will be a double bond between hydrogen, carbon and carbon. And in alkynes there will be a triple bond, carbon, triple bond, carbon. These are
Yes,
the
very good
hydrocarbons.
explanation. Very good explanation. I like it and I am
So these are
recollecting all this. Yes,
organic compounds. Most of them are used as combustion materials,
correct.
used as a fuels.
Yes, yes,
And some cyclic compounds are also there, aromatic compounds. They give aroma means smell. So when the
yes,
cyclic compounds are there, they are called as aromatic compounds.
yes,
So alkanes, alkenes, and alkynes, they are open chain compounds.
yes,
Then
yes,
aromatic compounds are cyclic compounds. They form a cycle, just like a circle like. So alcohols and phenols. For
yes,
open chain hydrocarbons, if hydroxyl group is added, they are called as alcohols. For cyclic or aromatic compounds, if alcoholic group is used, they are called as phenols. That is clear.
yes,
Open chain hydrocarbons mixed with hydroxyl ions, they are called as alcohols. If it is a closed cycle, aromatic compounds, hydroxyl groups are added, they are called phenol. Hydroxyl group is nothing but OH minus. That's a radical. Similarly, amines, NH2 group, organic compounds containing nitrogen, classified as primary, secondary, tertiary based on the number of alkyl groups attached to the nitrogen. Amine groups, NH2 group. That's a functional group. If functional group is nothing but if you add some ligand, the properties of that will change according to the ligand. So
yes,
carbohydrates, proteins, nucleic acid, these are all biomolecules essential for the life. They involve in energy storage, structural function, and genetic information.
yes,
Then titrimetric analysis. By making titrations, quantitative chemical analysis methods involving measurement of titrant value to react with an analyte. That is titrimetric
an
analysis.
example
Suppose,
titrimetric analysis.
so for example, there is one solution. So sodium hydroxide solution is there. How much
NaOH.
amount of
Yeah,
so sodium hydroxide solution consists of sodium hydroxide solute and water as
yes,
solvent.
yes,
So
yes,
how much amount of the sodium hydroxide is there present in that? So
yes,
to do that, to know that, if you take that sodium hydroxide in one burette and take one sulfuric acid in known concentration of sulfuric acid in one funnel and slowly make a titration, add sodium hydroxide into the sulfuric acid, there will be an indicator. Suppose if it becomes neutral, that means what? All this sulfuric acid is neutralized with the sodium hydroxide. That means there is a proportion between sodium hydroxide and sulfuric acid. So for this much of sulfuric acid, how much amount of the sodium hydroxide is there?
yes,
So that is called as titrimetric analysis.
yes.
Next,
Next, loss of.
there are fundamental principles governing the ways in which the chemical elements combine to form the products. They are the law of definite proportions, law of multiple proportions, law of conservation of mass. These are the laws of chemical combination. Suppose A gives some product R, that means 1 mole of A giving some product R. Or A plus 2B gives R, that means 1 mole of A with reacting with 2 moles of B give 1 mole of R. That is a definite proportion. So same A plus B gives some D. 1 mole of A, 1 mole of B is giving one product, 1 mole of A, 2 moles of B is giving another product. That is law of multiple proportions. So we know that the atom and molecule, what are they? The mass of an atom is average weight of atom, and while the mass of molecule is average weight of sum of the weights of all atoms in that. Similarly, empirical molecular formula we know it's again repetition,
Yes.
and the chemical equation is stoichiometry. The chemical equation represents the chemical reaction, where the stoichiometry gives the information about the proportion of the reactants and products participating in the reaction.
Yes.
So psi is a wave function. Psi square is a probability density function related to the radius. For each orbital, it will have its own value. This was explained by Schrodinger wave equation.
Yes.
Why?
Yesterday you didn't explain this information. Yes, that I expected.
That time I didn't know that. So
Yes.
wave function, how that wave is related with the radius for 1s orbital, for 2s orbital, or for various orbitals, there are equations related to in terms of r. So
Yes.
these describe how wave function and probability density of electrons vary with distance from the nucleus, 1s and 2s and so on. Psi is the wave function, psi square is the probability density function. There
Yes.
is electron spin and spin quantum number. Electron spin is a fundamental property with the spin quantum number indicating the direction of electron spin. So one orbital can accommodate two electrons. One electron in one direction, rotating, spinning around its own axis in anti-clockwise direction and clockwise direction. So that spin quantum number will indicate the direction of the electron in which it is rotating, whether it is clockwise or anti-clockwise. Passen's rule, it predicts whether a bond will be more covalent or ionic. Based on the bond energy, you can say that. Based on the charge and size of the ions. Dipole moment, when a molecule is there, the charge will be distributed at the ends. One end partial negative charge, the other end positive charge.
No, that is
Partial
separation
positive.
of charge in molecule. That is called dipole moment.
Yes.
Example,
That is two poles will be there. So for example, all organic, all
compounds, organic
magnet, for
compounds.
example, you take magnet you take, for example,
Yeah.
there is north pole, there is south pole. So north pole is positive, south pole is negative. That means the distribution of the charges partially change to two ends. So the dipole moment is a measure of separation of degree in molecule, indicating that the product of distance between them, charges, and the charge, that is dipole moment.
Yes.
The chemical bonding that refers to the delocalization of electrons across multiple structures, stabilizing molecules. That means continuous movement of electron clouds in other words you can say. That is resonance, movement of that delocalization of the electrons across multiple structures. That is called as resonance.
Yes.
Then even for example, you take a benzene molecule.
Yes.
Benzene molecule, you see, there will be alternatives, double and single bonds. So that electron, while it is rotating, sometimes that double bond will be there, sometimes there will be single bond because of that structure. So like that, there will be resonance of the de- uh, delocalization of the electron across the structures. Bond order, bond length, and bond energy. When the bond is there between two atoms, the order and length and energy will describe the distance and strength of the bonds. Next,
Yeah.
hydrogen bonding. It is a bond, strong intermolecular force, where a hydrogen atom is attracted towards electronegative atoms in other molecules. So it's important in water's properties. Hydrogen bond is there in water. There is hydrogen, there is oxygen. Oxygen is electronegative element. HF, for example, hydrogen fluoride. That is, fluorine is electronegative element. There is a hydrogen bond like that. So thermodynamic point of view, there is a system, there is surroundings. If you consider one system, for example, human body is a system we are observing. So
Yes.
surrounding other part of the universe. So
Yes.
universe is thermodynamic point of view, universe is divided into two categories. One is the system, which is
Correct.
under observation. The surroundings, which is other than the part universe system. Other than the system,
1 second, sir. Hello, Mohammed
yes.
sir. Good morning.
Yeah, the fingerprint is there, not correct. So you
Why?
need to do different one. You need to do different one. You need to lay your hand, not to just touch. That only to lay the hand. The problem here is that the line are in the paper it should appear in the print. You get it, man?
Yeah, I have taken with the blue
The
ink
line
only.
on your finger. Can you see what I said before? You forget to read. On the line on your phone. You get it, man?
Yeah, yeah, yeah. Tell me.
Hello.
Yeah, yeah. Please tell me.
Yeah, your finger. The line on it should appear on the paper. So do different one and send it to me.
Okay.
When you lay your tongue in the front of the line and then the first line, you should lay it so you can show that the second one to do the same thing, the third one the same thing, the fourth one the same thing, the big finger too, the big finger part like they do it the same way. You get it, man?
Yeah, but that is I have taken morning. It's okay. Once again, I will take and I'll send to you.
Okay, again, send it to me. All right.
Yeah. Okay.
All right. Again, send it to me. Wow.
ఓకే సార్
Kannada.
ఎక్స్ప్లెయిన్ ఆ ఫింగర్ ప్రింట్ సరిగ్గా రాలేదంటాడు నీకు పెట్టాను చూడు ఫొటోస్ పెట్టాను చూడు
చూసిన క్లారిటీ లేదు, నేను చూస్తున్నా. కొంచెము థిక్గా ఉంది.
అవును మరి ఇంకా తిక్ అనవసరంగా పెట్టానేమో నేను
ఎక్కడ థిక్ అదే?
అది
ఇంక్ ప్యాడ్
ఇక్కడే
తీసుకోవాలా?
వేరే ఫ్రెండ్ ఇచ్చాడు
ఇంక్ ప్యాడ్ అని ఉంటుంది.
ఇంక్
స్టాంప్
ప్యాడ్లో
చేస్తాను చూడు.
తీసుకోవాలా నేను అది ఒకడు
స్టాంప్
ఇంక్
స్టాంప్
ఇచ్చాడు
వేసేదిరా.
ఆ?
స్టాంప్ వేస్తాం కదా, రబ్బర్ స్టాంప్.
అది లేదు అది ఉండింటే నాకు ఇంక
అది తెచ్చి
ప్రాబ్లం
కొనుక్కొచ్చుకోవాలా, లేదంటే ఎట్లా?
అది దొరకలా ఇక్కడ నేను చూశాను అన్నీ చూసేసి గమ్మున
దొరుకుతుంది
అయిపోయాను
దొరుకుతుంది. నువ్వు నువ్వు చూడు, దొరుకుతుంది మార్కెట్లో.
ఇప్పుడు ఎంత 10 అయిపోయింది టైము వాడు చూడు వాడు ఇప్పుడు సరిగా అంటే కొంచెం ముద్దగా వచ్చిందనే ఏంది చూడు
ఆ, రెండు మూడు శాంపుల్స్ తీసి పంపేవాడికి.
అవును ఇంకా ఫింగర్
ఇంక్ ఉందా?
ప్రింట్ అంటే అవును కొంచెం ముద్దగానే వచ్చింది కనపడతా ఉంది వాడు దొంగనాయాలు
కానీ వాడు రూల్స్ ఉంటాయి కదా.
మళ్ళా చేయాలంటే తలకాయ నొప్పి అయిపోతుంది
ఈ సాఫ్ట్ కాపీ ఇచ్చినాడు కదా నీకు ఇదే.
సాఫ్ట్ కాపీనే ఉంది నేను అనుకున్నా ఈరోజు
ప్రింట్అవుట్ తీసుకొని
మళ్ళా అది చేయాలంటే తలకాయ నొప్పి
అలా
వస్తుంది
ఏదైనా నువ్వు బుక్ షాప్కి పోయి ఇంక్ ప్యాడ్ కావాలను. లేట్ అవుతుంది పో.
లేదు లేదు 10 ఉండవు షాపులు ఉండవు ఇప్పుడు ఎప్పుడో క్లోజ్ అయిపోయింటాయి ఈరోజు
ఇంకా
కుదరదు
ఏం కాదే.
ఇంకా మార్నింగే నేను పంపించాల్సిందే వానికి ఇప్పుడు నేను చేయలేము అదంతా
ఆస్ట్రేలియా పెద్ద ఇంగ్లాండ్ అంటావా? ఇండియాలో 11 గంటల పైన ఉంటాయి.
ఆహా ఉండవులే నేను నా దగ్గర ఉన్న ఇంక్ ప్యాడ్ అది ఇంక్ ప్యాడ్ ఉందా నా దగ్గర లేదే నా దగ్గర
ఉండాలి ఇంక్ ప్యాడ్.
ఇంక్ ప్యాడ్
నువ్వు
కాదు
దొంగ సంతకం పెట్టాలి స్టాంప్ వేసే.
నాకు ఎలక్ట్రానిక్ మెయిల్ ఉంది అట్లా కొట్టేస్తే పడిపోతుంది నాకు అది ఉంది నేను థీసిస్ల కన్నిటికీ అదే
వాడు డిఫరెంట్ డిఫరెంట్ అడిగాడు కదా వాడు.
దొంగ నా కొడుకు వాడు నేను అనుకున్నా పొద్దున్నే పెట్టేటప్పుడు అనుకున్నా వీడు మళ్ళా ఇది ముద్దుగా ఉందేమో పంపిస్తాడు అనుకున్నా
రైట్ థంబ్ అన్నాడు, రైట్ ఇండెక్స్ అన్నాడు, డిఫరెంట్ డిఫరెంట్ ఉన్నాయి కాబట్టి నీకు వర్కౌట్ కాదు. నీకు
సరే సరే
కంపల్సరీ.
ఓకే ఓకే వీఆర్ ఇన్ రికార్డింగ్ సెషన్ ప్లీజ్ కంటిన్యూ ఐ విల్ డూ దట్ వన్
That is the hydrogen bond where electronegative elements are attached with the
Yeah.
hydrogen. Instrument surroundings, so you know. Entropy is nothing but the measure of disorder or randomness in a system
Mm.
related to second law of thermodynamics.
Mm.
Enthalpies of combustion and formation. When an organic compound is combustion reacted with oxygen and gives some energy, that is called as enthalpy of combustion.
Mm.
And when that molecule is formed from its elements, that is called enthalpy of formation.
Mm.
Then equilibrium constant we are talking about, it is the concentrations of products divided by the concentrations of the reactants.
Yes.
So if that constant is defined in terms of
Mm.
pressures or concentration, that is like that. Ionization of water and pH scale. When water is ionized, H plus and OH ions will be forming. The concentration of H plus is called as pH, negative logarithm of H plus ion. So that value varies between 1 to 14. pH is equal to 7 indicates neutral solution. pH less than 7, acidic solution. pH more than 8, 7, it is alkaline solution.
Mm.
Then common ion effect. When a chemical equilibrium is attained, if you add one common ion that is there in that solution, so that effect will be there. So according to that, there will be shift in the equilibrium caused by adding common ion. Then electrolytic and metallic conduction. Suppose electrolytic conduction occurs through ions in a solution, while the metallic conduction happens via electrons in metal. So through ions, ion is nothing but when charge is there, that is an ion.
No, no, negative. Negative charge.
Any charge is ion. If it is negative charge, it is called as an ion.
Ah,
Ion means any charge.
okay. Positive also.
Yes. Then cell potential gives energy change. The potential difference of a cell relates to the free energy change of the electrochemical reactions. Then collision theory of gases. What this collision theory says, that is gaseous molecules always continuously make some elastic collisions among themselves. That is called as collision theory. That value changes with respect to temperature. The law of periodic properties, element shows the periodic trends in properties such as electronegativity, atomic sizes in the periodic table, that also we know. Similarly, the lanthanide contraction, gradual decrease in the size of lanthanide atoms due to the poor shielding of F electrons. Then Werner theory of coordination compounds. That means it describes how metal atoms bond with the surrounding ligands in a complex ions. Then crystallization is a purification process where a solid forms from a liquid or gas, separating it from its impurities. Crystallization is the most sophisticated separation techniques to get the materials in their purest form. Then qualitative analysis in organic chemistry. That means presence. If it is techniques that are used to detect the elements like nitrogen, sulfur, halogen in any organic compounds, that is called as qualitative analysis. Next slide.
Yeah.
Tetravalence of carbon. Carbon can make four bonds with four different elements. That is the specialty of the carbon. Maximum possible electrons that can take part for any atom is four. Because if it loses, it gets nearest noble gas composition, or if it gets four electrons, it will nearest
Yes.
nearest electron configuration. Therefore, carbon has a special property having valency 4. Then free radicals, carbocations and carboanions. Reactive species in organic chemistry where the atoms or molecules possess unpaired electrons, positive or negative charges. They are called as free radicals.
Yes.
Then hyperconjugation. This is a concept of delocalization of the electron in a molecule that stabilizes the carbocations and contributes to its structure of organic molecules. So, delocalization of the electrons takes place to keep that in a stable structure.
Example?
Then
Example, hyperconjugation, delocalization of electrons means what? It changes from their location?
suppose a molecule is there,
Yes.
it will have certain electrons.
Yes.
Those electrons will move in such a way that it will be more stable.
Okay.
For example, we have chair.
Yes.
If that chair something some damage is in some side, what we take? We take one small
Stone or,
stone
yeah,
that end and
anything
will
for
get stable
adjusting.
like that.
Yeah,
So,
delocalization. Yeah.
but the electrons are also delocalizing in order to make it composition structure flexible and stable.
Yes, yes, I
So
understand.
isomers are okay.
Yeah.
Geometrical a type of stereoisomerism, that means structural isomerism, where molecules with the same connectivity differ in the spatial arrangement of atoms around a double bond. Geometrical isomerism, that is called as same structure. Isomerism means same structure,
Same
sorry,
structure.
same molecular formula, different structure. So arrangement of that.
Yes.
Then polymerization of alkenes and alkanes because of the bonds, double bonds and triple bonds, chemical reactions where smaller monomers units join to form larger polymers like plastics. That is called
Yes.
as polymerization.
Yeah.
Electrophilic substitution and aromatic compounds. Electrophilic means fill means love.
Yes.
So electron love change then electric
Electrophilic.
electrophilic.
Philic. Yeah.
So that is substituted in aromatic compounds. A reaction where electrophile
Yes.
replaces a hydrogen. Hydrogen, carbon hydrogen bonds లో ఒక hydrogen తీసేస్తే that is called as electrophilic substitution. Hydrogen atom, then aromatic compound like benzene, electrophilic substitution అంటాం దాన్ని. Substitution reactions in halogen compounds. Halogen compounds undergo nucleophilic substitution, where a halogen atom is replaced by another group. Nucleophilic means nucleus is there.
Yeah.
It loves nucleus. So that is called nucleophilic substitution. Atom is substituted by these halogen compounds because of nucleophilic substitution, that process. Then Riemann-Tiemann reaction, a chemical reaction used to form phenolic aldehydes from phenols. Phenol group, phenol group is OH.
Yes.
ఒక సైక్లిక్ కాంపౌండ్ తీసుకుంటే OH గ్రూప్ ఉంటే దాన్ని ఫీనాల్ అంటాం. దట్ ఫీనాల్ OH group. If another atom, aldehydes means if it becomes aldehyde, from aldehyde is CHO.
Yeah.
So if H is removed, it becomes C is removed, it becomes OH. That is called according to the Riemann-Tiemann equation.
Yes.
Grignard reagent is organomagnesium compound used to form carbon-carbon bonds in the organic synthesis. That is one analytical reagent.
Yeah.
Diazonium salts, they are the organic compounds used as intermediates in the synthesis of dyes and other chemicals. Dyes means colors.
Example?
Dye industries, pharmaceutical products.
Okay. Okay.
Similarly, aldol condensation, a reaction between aldehydes and or ketones. Aldehyde means CHO,
Yeah.
ketones means CO2. These are the functional groups to form larger beta hydroxy carbonyl compounds. Beta hydroxy means second carbon ki hydroxyl group carbonyl compounds. They are important in organisms. That is one type of the chemical reaction. Aldol condensation is a process. So nucleic acids like DNA, deoxyribonucleic acid, ribonucleic acid, these are the molecules responsible for storing and transmitting genetic information in the living organisms. Similarly, vitamins. Similarly, vitamins.
Yeah.
These are the compounds required in small quantities for essential biochemical reactions in the body.
Yes.
Similarly, hormones. These are all the chemical machines produced by endocrine glands that regulate various physiological processes in living organisms. హార్మోనల్ ఇంబ్యాలెన్స్ ఉంటే మనకు డిఫరెంట్గా బిహేవ్ చేస్తుంటారు. టైం పడుతుంది ఏమి వాటిల్లో లేదు 1 hour పైన పడుతుంది. Next,
Yeah.
These are the chemical medicine produced by endocrine glands that regulate the various physiological processes in the living organisms.
Yes.
Then preparation of inorganic and organic compounds. So, Mamulu, they are called as synthesis.
Yes.
Methods are there to synthesize compounds such as Morse salt and acetanilide in laboratories. So,
Yes.
different laboratory reagents are there.
Yes.
Then qualitative salt analysis means identifying the cations and anions in a simple sample based on their chemical activity. Qualitative means whether they are present or not to identify. Then kinetic study of reactions. It is a study of reaction rates and a mechanism to understand how reactants transform into the products. Mechanism means how the reaction is happening inside. A is giving some product R. Directly A is giving R or A becoming some other A dash and that A dash is becoming A double dash and then it is becoming R. That is the
Yes.
mechanism.
Yes.
So calculation of empirical molecular formula based on the information we can do it. And Vanta factor is a measure of the effect of solutes on colligative properties, correcting for ionization or association in solutions. When we go in detail, all of these concepts we can read out.
Yeah.
Hydrolysis of salts and pH of solutions, the process in which salts react with water to produce acidic or basic solutions.
Solutions.
The pH by the nature of the ions. So if pH is more than 7, it is a basic. It is less
Neutral.
than
Neutral.
7.
pH is 7 neutral. Below 7 it is called acidic. Above it is called basic.
Basic or alkaline also we can say.
Yeah, alkalines. Okay.
Next, solubility product. The equilibrium constant for the dissolution of sparingly soluble salts predicting the solubility under various conditions. It's like an equilibrium constant.
Yes.
Then buffer solutions, it resists changes in pH for smaller changes of acid or base made of weak acids and bases and their salts. Then Colruy's law, it states that the limiting molar conductivity of an electrolyte is the sum of the individual contributions of its ions. Already we have seen. And this next equation is a formula that relates the electromotive force of a cell to the concentration of the reacting ions used in electrochemical calculations. Then lead accumulator.
Lead accumulate.
Hmm. Uh, so a rechargeable battery made of lead electrodes in a sulfuric acid solution widely used in vehicles. మన
H2SO4.
బాటిల్లో
Usually we are using H2SO4 for vehicles.
బ్యాటరీ మనం ఛార్జ్ అయిపోయిందంటే మన సల్ఫ్యూరిక్ యాసిడ్ వేస్తాడు వాడు.
Okay. Okay.
బ్యాటరీ రీఛార్జ్ అదే వేస్తుంటాడు. మన
Okay.
వీళ్ళు వాడేది కూడా అదే.
Okay. Okay.
అమరాన్ వాళ్ళు కూడా అదే.
Okay. Okay. Next.
నెక్స్ట్
Fuel cells.
fuel cell is an electrochemical cell that convert chemical energy from fuel into the electrical energy through a redox reaction, offering efficient power generation. All electrolytic cells are fuel cells only.
Yes.
This Arrhenius theory, already we have said, A is equal to A naught e power minus E by RT. This explains the effect of the temperature and reaction rates, proposing that molecules will collide with sufficient energy to react. That energy is called as activation energy.
Arrhenius.
That is the minimum.
Yeah.
Arrhenius. Some people call it as Arrhenius.
Yeah. Arrhenius. Okay.
So the minimum energy required for the reactants to form products in a chemical reaction is called as activation energy. That is described in the Arrhenius equation. A is equal to K is equal to K naught e power minus E by RT. That E is activation energy.
Yes.
Half-life of the reaction, the time required for half of the reactants in a reaction to be consumed is important in study of the reactions. Then catalytic behavior of the transition metals. The transition metals exhibit catalytic properties due to their ability to change in oxidation states and form complexes. That is the reason they are used as the catalyst.
Yes.
Next,
Next. Lanthanoid.
lambda matters are a phenomenon in which
57.
the atomic radii of the electrons decrease across the
Why
series.
it is called as a lanthanoid? This one.
Lanthanides, there is a series in periodic table,
Yeah,
no?
yeah, I know.
Lanthanides
57th.
are
Yeah, I
units.
know. Yeah,
Along the period,
yeah.
the atomic radii of the lanthanides decrease across the series,
Okay.
affecting the properties of the subsequent elements. That is called as lanthanide contraction. There would be a reason behind it.
Yes.
And coordination number, it refers to the number of ligands bound to the central atom of a coordination compound, affecting its geometry and reactivity. Now, more the number of ligands, the less will be the geometric reactivity, like that.
Yes.
Denticity and chelation.
Denticity.
Denticity refers to the number of donor atoms a ligand uses to bind to a metal ion, while chelation involves the multiple bonds stabilizing the compound. This is regarding to the metal ions, metallic bonds.
Yes.
Crystal field theory. It describes how ligands affect the energy of d orbitals in transition metal complexes, leading to phenomena like color and magnetism. This is crystal field theory. And
Yes.
chromatography is a technique that separates components of mixture based on their interactions with a stationary phase and a mobile phase. Selective, other words, we can say chromatography is selective adsorption. Adsorption is settling of particles on the surface. Next,
Yes.
titrimetric analysis of acids and bases. Already you have seen a quantitative analytical method used to determine the concentration of an unknown acid or base by titrating with a titration of known concentrations.
Yes.
So then lyophilic and lyophobic salts. Colloidal systems where lyophilic salts are solvent attracting and stable, while lyophobic salts are solvent repelling and less stable. Philic means love, phobic means afraid.
Yes.
So a colloidal system, that means big solution. It's not a homogeneous solution. A big solute particles are there. So lyophilic salts are solvent attracting and stable, while lyophobic salts are solvent repelling and so they're less stable. That is lyophilic and lyophobic salts. Detection of fundamental groups in organic compounds. We are saying that different functional groups are there, like hydroxyl groups, carbonyl group, carboxyl groups, amino acid groups, like that. So these are called as functional groups. To detect that functional group, there are techniques available. Cations in quantitative salt analysis. So analytical chemistry questions we are discussing now. It involves identifying the ions like lead, carbon, copper, aluminum in a solution through chemical reactions, forming distinct properties, precipitates or color changes. Have you done? We have done plus two. In plus two, we do some salt
Experimental.
analysis.
Yes, yeah, we have done.
Yes,
Yes, we have done.
that is the cation in quantitative. Cation separate, anion separate.
Yes, yes, yes. I understood.
Similarly, anions and quantitative salt solutions like chlorine group, chloride group, nitrogen, nitrate group, sulfate group, using chemical reactions, which may result in precipitates, color changes, or gas evolution. So, based on this techniques, we make salt analysis. Suppose if you find out lead as positive ion, sulfate negative ion, the compound that present in that is lead sulfate, like that. Next,
Yeah.
more salt precipitation. Synthesis of ferrous ammonium sulfate, a double salt used in redox titrations for its stability. That is, more salt is one reagent.
Mm.
Similarly, potassium. The synthesis of potassium aluminum sulfate used as a coagulant in various chemical industries. Normally, for waters also, we were using some paticabellum.
Yeah, I know.
It's potassium.
Yes.
సో దాంట్లో ఉన్న సాల్ డిజాల్వ్ అని అన్ని దగ్గరకు వచ్చి అతుక్కునేస్తాయి. దట్ ఈస్ ప్రాసెస్ ఆఫ్ కోఆగులేషన్.
Mm.
Iodoform precipitation, a laboratory method to synthesize iodoform, CHI3. Whereas chloroform,
Yes, yes,
CHCl3.
yes. Yeah, Mattu
This is
Mandu.
iodoform, CHI3,
Yes,
used
yes.
as antiseptic and a reagent in organic chemistry.
Yes.
Similarly, enthalpy of solution of copper sulfate. The heat absorbed or released when copper sulfate dissolves in water, demonstrating exothermic or endothermic process. That is enthalpy of solution. Similarly, enthalpy of neutralization. It is the heat when an acid reacts with a base to form water. Typically exothermic, measured in titrations of strong acids and bases.
Yes.
Next, kinetic study of reactions. This is an investigation of the rate and the mechanism of the chemical reactions, allowing the determination of reaction orders and rate constants.
Yes.
When Markovnikov's rule, it is in organic chemistry, it states that the addition of hydrogen halide, that is, halide means fluorine, bromine, bromine, iodine, astatine. These
Yes.
are the
Yes. I know.
halogens
Yeah.
to an unsymmetrical alkene.
Yeah.
Remember,
Yes.
one unsymmetrical alkene, the hydrogen attaches to the carbon with most hydrogen atoms
Yes.
already attached,
Yes.
while the halide attaches to the carbon with the fewer hydrogen atoms.
Yes.
Okay, this HX is attached to the hydrogen atom with fewer hydrogen atoms, carbon
Yes.
with fewer hydrogen atoms.
Yes.
Similarly, peroxide effect, that is anti-Markovnikov's rule. In the
Yes.
presence of peroxides, the addition of HBr especially, HX were already we are saying that HX, hydrogen halides, according to Markov rule, they will be attached. But whereas there is an exemption for the bromine, that is called as anti-Markov rule. Instead of, in presence of these peroxides, if peroxide add చేసినామంటే, the addition of HBr to alkenes follows the opposite of Markov rule, where the bromine attaches to the less substituted carbon.
Yes.
Anti. Then ozonolysis of alkenes, a reaction where alkenes are cleaved using ozone, producing the carbonyl compounds such as aldehydes and ketones. Ozone is oxygen, O3.
Yes.
Oxygen atom is O, oxygen molecule is O2, ozone is O3. Three
Yes.
atoms
Yes.
of
That I know.
so
Ozone. Ozone three.
if
Yeah.
alkenes are there, double bond carbons are there, the double bonds will be separate cleaved using this ozone.
Yes. Yes. Yes.
Then polymerization of the alkenes and alkanes, that also a process where smaller monomers such as alkenes and alkanes join to form larger polymer chains used in manufacturing of
Yes.
plastics and
Yes.
polymers.
Yes.
The electrophilic substitution in benzene. So a reaction in which an electrophilic replaces a
What is
hydrogen
the
atom
benzene formula?
C6H6.
Yes.
It's a benzene ring
Yes.
because it's like a ring,
Yes.
maintaining the aromaticity of the compound.
Smell. It gives us a smell.
Smell. Yes. Aromaticity means smell.
Yes.
Almost all the cyclic compounds will give some smell.
Yes.
That's why they are called as aromatic
Aromatic
compounds,
compounds. Yes.
cyclic compounds, in other words. So, Friedel Craft alkylation and acylation. So, reactions in which an alkyl or acyl group, alkyl means CH, CH, C2H5 like that. Acyl group means uh, carbon group. Is
Yes. Yes.
groups.
Yes.
Is introduced to benzene ring via an electrophilic substitution mechanism catalyzed by Lewis acids like aluminum chloride.
Yeah.
Then directive influence in monosubstituted benzene, particularly the effect that a substituent group on a benzene ring has on the position. Ortho position means top, meta position means next.
Middle.
Paramorphism means down.
Low. Yeah.
So పక్క పక్కన ఆర్తో మెటా పారా,
Yes. Yes. I understood.
where subsequent substituents attach during electrophilic substitution, that is direct influence on monosubstituted benzene. Halogenous of alkanes. Alkanes అంటే saturated hydrocarbons.
Yes. Yes.
Replacement of hydrogen atoms in alkanes with halogen atoms typically occurring through a free radical mechanism. There is another such mechanism is there.
Yes.
So Ahars and Newman projections, methods used to visualize and represent the spatial arrangement of atoms in a molecule, particularly for conformations of alkanes.
Yes.
Conformations means variations in chain structures.
Yes. Homologous
When
series.
homologous series of organic compounds with the same functional group and similar chemical properties differing by CH2. Every
Yes.
time CH2 will be added, CH2
Yes.
add, and it will be there in the molecular formula. Clemenson and Wolff-Kishner reductions methods used to reduce carbonyl groups to alkanes. So with Clemenson reduction using acidic conditions like Wolff-Kishner reduction using this is some sort of reaction phenomena explained by these people. Then Cannizzaro reaction where aldehydes without alpha hydrogen atoms undergo disproportion to yield an alcohol and carboxylic acid under basic conditions. That is, we have seen Cannizzaro reaction differently. Beta hydrocarbon atoms said. That means alpha means first one, first carbon. Other than that, beta gamma and so on. So aldehyde condensation also reaction between aldehydes and ketones with alpha hydrogen atoms to form beta hydroxy aldehydes or ketones. Similarly, acidic strength of carboxylic acid. The strength of carboxylic acid is influenced by the nature of the substituent with electron withdrawing groups, increasing the acidity and electron donating groups, decreasing it. That is one acidic strength of the carboxylic acid. There is a definition for that.
Yes.
Next,
Yeah.
Grignard reagent is another one organomagnesium compound used from carbon-carbon bonds by attacking electrophilic carbon atoms useful in the organic synthesis. Similarly, nucleophilic addition to carbonyl compounds, a
Yes.
fundamental reaction where nucleophiles, that means which like nucleus, attack the electrophilic carbon of a carbonyl group, forming addition products such as alcohols. Nucleophilic addition to carbonyl compounds. Then enamines and imines, nitrogen containing organic compounds formed from aldehydes or ketones and amines.
Yeah.
These are important in intermediate organic synthesis, pharmaceutical products mainly.
Yes.
Haloform reaction, CHX3, a chemical reaction where halogens like chlorine or iodine react with methyl ketones to form haloform, that is CHX3,
Yes.
and a carboxylate ion.
What is X
X is
indicate for?
halogen. Halogen, fluorine, chlorine,
Anything.
bromine, iodine,
Anything
etc.
can be mixture with
That's
CH.
true.
Okay. Okay.
That is a common notation of halogen.
Yeah. That is a
Halogens are
nomenclature.
chlorine,
Nomenclature. Yeah.
common notation.
Yeah.
It's a
Qualitative.
common, it's not nomenclature, notation, conventional notation, in other words.
Yeah. In nomenclature, they
So,
used to write
normally
like
in
that CHS3.
for example, normally in mathematics, if you want to refer to a variable, what is that you consider that variable?
Yeah. A is equal to 3.
Most of the times we use x.
Yes.
If another variable is there, we take y.
No, X
That
means
is a convention.
anything closely related to that group of items. Anything can be represented as a X.
In mathematical relations, if there is a one variable, that variable will take it as x normally. That's a conventional way. That's a
Yes,
rule
yes,
of thumb.
yes.
Like
X
that,
can be
here
anything. X
also,
can be
for
anything.
halogens, we,
Yeah, X can be anything.
in mathematics, here that x is conventionally fluorine, chlorine, bromine, iodine, astatine.
Yes, yes. Next, qualitative
And then
detection.
quality, nitrogen, sulfur, halogens, and organic compounds, this already we have seen.
Yeah, techniques such as
Such as the techniques such as Lassing name test are used to
Lassagn's
detect these
in organic molecules.
elements in organic molecules by converting them to detectable forms to check
Okay,
whether they are there or not.
okay.
That is detection process, qualitative test. How
Estimation
much
of
carbon is there? How much
yes,
hydrogen is there? How
yes,
much
yes,
nitrogen is there? How much other elements are there in an organic compound? They are done by quantitative analysis methods to determine the percentage composition of these elements in a compound. This is essential for determining empirical and molecular formula.
Yes.
Okay.
Estimation of, yeah.
Similarly, Riemann-Tiemann reaction, a chemical reaction used to form orthoformal phenols from phenols using chloroform and alkali, important in organic synthesis. So these are specific reaction mechanisms
Reamer
studied
Tiemann.
by this
Yeah.
Riemann-Tiemann. You can call it as Tiemann also. Similarly, dehydration of alcohols. Alcohol is nothing but OH hydroxyl group. A
Yes.
reaction where alcohols lose water to form alkenes,
Alkenes.
typically catalyzed by acid and involving formation of
Carbo.
carbocation intermediate. So that is dehydration of alcohol. There is a step in organic chemistry. Mostly there are mechanisms,
Yes.
specified mechanisms.
Yes.
So the mechanism of electrophilic addition to alkenes, it involves the formation of a carbocation intermediate when an electrophile adds to the alkene, followed by the nucleophile attacking the decarbonic carbocation. Like some confusion will be there. We need to go in detail if any, if you want to go.
Yeah.
So oxidation of alcohols to aldehydes and ketones. Primary alcohols can be oxidized to aldehydes. Alcohol is OH.
Yes.
If another
Yes. Yes.
uh,
And
can oxidize to aldehydes and further to carboxylic acids. Aldehydes means CHO.
yes. Yes. That I know.
Carboxylic group means COOH.
Yeah.
While secondary alcohols oxidize to ketones. Like that.
Yes. Okay.
The mechanism of nucleophilic substitution in halogen compounds. Already we have seen it involves the substitution of a halogen atom in a molecule by a nucleophile, either through a one-step
Or
or
two step.
two-step mechanism,
Okay.
SN1, SN2.
Yeah.
That SN1 mechanism is very specific in organic chemistry.
Yes.
Similarly, if there is two steps SN2 mechanism, so according to that, the nucleophilic substitution will be taking place in halogen compounds. Environmental of DDT, dichloro, something like is there. These compounds, although widely used, are known for their environmental hazards, including ozone depletion, freons, and toxicity of the DDT. This DDT is an insecticide.
Yes.
Then preparation and properties of aldehydes and ketones. These compounds are prepared through the oxidation of alcohols and characterized by their carbonyl group C11O,
Yes.
undergoing reactions like nucleophilic addition. Next, isomerism in hydrocarbons. Structural isomers, change in the structure, have different arrangements of the atoms, while stereoisomers differ in the spatial arrangement of the atoms. So these are important for understanding the reactivity and properties of hydrocarbons. Stereoisomerisms, structural isomerisms. Then aromaticity of benzene. Benzene stability arises from its delocalized pi electrons. There is a parallel bond, there is a vertical bond.
Yes.
Pi bond means vertical.
Yes.
Parallel sigma. So they follow some Huckel's rule. Huckel's rule is there, making it resistant to addition reactions and more prone to substitution reactions.
Yes.
Huckel's then colligative properties and abnormal molar mass. What is that? Properties like boiling point elevation and freezing point depression depend on the number of solute particles, and the deviations from ideal behavior lead to abnormal molar concentrations. Then ideal and non-ideal solutions. Ideal solutions follow Raoult's law exactly, where intermolecular interactions are similar between solute and solvent, while non-ideal solutions deviate due to the differing interactions. In Henry's law, this law states that the amount of gas dissolved in a liquid is directly proportional to its partial pressure above the liquid. It is crucial for understanding gas solubility. Then deviation from the Raoult's law. This is non-ideal solutions, so positive or negative deviations from the Raoult's law due to differences in intermolecular forces between the solute and the solvent.
Yes.
critical temperature and critical pressure. The temperature and pressure above which a gas cannot be liquefied, no matter how much pressure it is applied. It is important in understanding the phase behavior of the gases. Certain beyond certain temperature, you cannot convert them into liquids.
Okay.
As per the rule of thumb, we know that gases can be converted to liquid, liquid can be converted to solid.
Mm.
But a certain temperature, beyond that, it's not possible.
Yes, yes. Surface tension.
Surface tension is a property of a liquid due to cohesive forces between the molecules at the surface, leading to the minimal surface area important for capillary action and bubble formation. If you take waterfalls, it
Yes.
will be in the form of small drops. That is because of the surface tension. It is
Yes.
the forces that cohesive forces that make
While
them to
while
be.
while while bathing also, if you apply your soap while pouring water,
Yes,
it gives a bubble formation. That
yes,
that is
because of the
also.
cohesive forces between molecules at the
Yes.
surface.
Yes.
So that makes the surface to be minimum.
Yes.
That is the property. If the surface is to be minimum, it's a capillary action also will be there.
Yes. Capillary
Capillary action
action.
means it passes through small holes.
Yes. Yes. Next, vapor
Then
pressure.
the pressure that is exerted by the vapor of a liquid in equilibrium with its liquid phase at a given temperature is important in phase transition and colligative properties, that is vapor pressure. Then partial molal quantities. These describe a change in a thermodynamic quantity when 1 mole of a component is added to a solution.
Important.
The
Solution
property,
thermos. Yes.
partial molar property. The definition is not clear. Okay. Then freezing point depression and boiling point elevation. It is a colligative property where the freezing point of a solution is lower and the boiling point is higher than that of the pure solvent due to the presence of the solute. Then electrochemical series, a list of elements ordered by the standard electrode potentials, important for predicting the spontaneity of the reaction. Standard electrode potentials for each metals are there. So that the more the electron potential difference, the more will be the passage of electrons. That is one. Then over potential, the extra voltage required to drive an electrochemical reaction faster than the equilibrium rate. It's relevant in electrolysis is and battery technologies. That is over potential. Additional voltage that is required. Then standard electrode potential. The potential difference between an electrode and its ion in solution under standard conditions is crucial for understanding the cell potentials. Then Faraday's laws, these laws quantify the relationship between amount of substance produced at an electrode and the quantity of the electricity passed through an electrolyte. So, for one equivalent weight of a metal, 9,000, 96,000 coulombs will be there.
Yes.
That is one Faraday.
Yes. On Faraday.
Then Gibbs, 1 Faraday is equal to 96,000 coulombs. That is
Yes.
charge. Gibbs energy and electromotive force. The relationship between the Gibbs energy of a cell reaction and its EMF determines the spontaneity of the electrochemical reactions. Then collision frequency in theory, the number of collisions that occur per second per unit volume in a gas, influencing the reaction rates and transport properties.
Yes. Next. Maxwell
Maxwell-Boltzmann
Boltzmann constant.
distribution law. It describes the distribution of speeds or energies among particles in a gas, foundational for understanding molecular motion and reaction kinetics. Maxwell-Boltzmann distribution law.
Yeah, that is very
Energy
important
system.
in
It's an advanced concept.
yeah, because in IIT they may
Foundation
ask.
for understanding molecular motion and reaction kinetics.
Yes.
How the molecules are moving and the reaction, how they are
Yes.
happening. So, order and molecular type of reaction, the order is sum of the
Exponents.
exponents in the rate law. For example, rate is equal to K into CA, CA square.
Yeah.
Like that, the power raised to the concentration is called as the order.
Yes.
While the molecularity refers to the number of reactant molecules involved in the reaction. Okay. Then
Yeah.
transition state theory that proposes the transition state is formed during the course of a reaction. That is what A giving some product R. A directly is not converting into R. A becoming A star, that A star is becoming some other B star, and then it is becoming B. There are various states. They are called as transition states.
Yes.
Isotopes and isobars. Isotope are atoms of same element with different number of neutrons, while the isobars are the same mass numbers but are different in elements, different elements. Important in nuclear chemistry. The Heisenberg uncertainty principle, Schrödinger equation. These are the fundamental principles in quantum mechanics describing the behavior of particles at the atomic scale, particularly the electrons.
Yes.
The principles of Michael's formation, Michaelis formation. Michaelis means a clump of molecules.
Yeah.
Michaelis form the aqueous solution of surfactants when the concentration exceeds a certain level, significant in colloidal chemistry. Colloidal chemistry means solution is a homogeneous mixture, suspension is a heterogeneous mixture, in between them. So the size of the suspended materials will be less, and the size of the dissolved material more than the dissolved material, that is colloid solution. So this is important in colloidal chemistry. Critical
Yes.
mycelic concentration, the concentration at which surfactant molecules spontaneously form mycel, is important in understanding detergents and biological membranes. Then Fermi level in semiconductors, so energy bands are there. So the energy level at which the probability of finding an electron is 50% important in semiconductor physics and material science. That is Fermi level in semiconductors.
Fermi level in semiconductors. Yeah.
The electron band theory of solids. It explains there is a valency band is there, uh, semiconductor valence, some bands are there. It explains the electrical conductivity of materials by describing the energy bands found by the overlapping atomic orbitals, distinguish conductors, semiconductors, and insulators. Okay. Then coordination chemistry and transition metals. It expresses the bonding and behavior of transition metals in complexes including crystal field stabilization and Ligel field theory.
Yeah.
Next,
Next, last slide.
activation and orientation in aromatic compounds. This describes how substituents influence the reactivity and position of further substitution on an aromatic ring. Important in electrophilic aromatic substitution. That means aromatic compounds are there like benzene.
Yes.
How the substitution influence the reactivity? Once for first substitution, to what at what rate it will react, and
Okay.
further
Now, with
substitution
element you are substituting C2H6, C6H6.
C2H6, it's a structure ring compound.
Yes.
In the top position, top carbon will be substituted first.
Okay.
Then further another carbon like that.
Okay. Okay.
So the priority of substitution for what? How?
Okay.
This
Okay.
that depends on electrophilic aromatic substitutions.
Okay.
Then hydrogenation and dehydrogenation reactions. Hydrogenation means addition of hydrogen to unsaturated compounds, while dehydrogenation removes hydrogen from both significant industrial chemical process. Then carbohydrates, optical activity. Many sugars are optically active due to the presence of chiral centers, influencing their physical properties and biological properties. That is fructose and glucose. We are saying now
Yes.
optical isomers. Left-handed, right-handed. Glucose also it is like this. Glucose and fructose mainly. Then
Yes.
enzymes act as biological catalysts by lowering the activation energy of the reactions following Michael-Menten kinetics. Then denature of the proteins, the disruption of protein structure by heat, pH, or any other chemicals, leading to loss of their function and structure. It is critical in
What is the
both
structure of protein? How do you can draw that
different
proteins?
proteins will have different structures.
Okay. 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 by heat, by
Protein
pH
is a
change.
general name. Protein is a general name where amine groups and hydroxyl groups, carboxyl groups are added
In biochemistry. Okay.
added to carbon compounds. Then here you will end.
Yeah. So denaturation of proteins. Okay. So
Destruction of the protein structure by heat or pH or chemicals.
with this one we are closing the session today. Okay. Wait one
Okay.
second.